Okay, this is the Professor, CBMD PhD, and today is Wednesday, July 5th, 2023. It is 7:17 and 56 seconds, p.m. Eastern Standard Time, and today's research, quantum technology. So let's jump to it here. The scientific researchers discover finding the flux of quantum technology, date July 5th, 2023. Source, University of Pittsburgh. We interact with bits and bytes every day, whether that is through sending a text message or receiving an email. There is also quantum bits or qubits that have critical differences from common bits and bytes. And these photons, particles of light, can carry quantum information and offer exceptional capabilities that can't be achieved any other way. Unlike binary computing, where bits can only represent a 0 or 1, qubit behavior exists in the realm of quantum mechanics. Through superpositioning, a qubit can represent a 0, a 1, or any proportion between. And this vastly increases a quantum computer's processing speed compared to today's computers. Experts are now investigating the inside of a quantum dot-based light emitter. Learning about the capabilities of qubits has been a driving force for the emerging field of quantum technologies, opening up new and unexplored applications for quantum communication, computing, and sensing. Quantum technologies are important for a number of fields, like for banks protecting financial information or providing researchers with the speed needed to mimic all aspects of chemistry. And through quantum entanglement, qubits can communicate across vast distances as a single system. As scientific investigators point out, photon-based quantum technologies rely on single photon sources that can emit individual photons. And these single photons can be generated from nanometer scale semiconductors, more commonly known as quantum dots. And similar to how microwave antennas broadcast mobile phone signals, a quantum dot acts as an antenna that radiates light. As by performing rigorous analysis, they discovered a quantum dot emitter, or a nanometer scale dipole antenna, traps a large amount of energy. The outer regime operation of a dipole emitter is well understood, but this is really the first time a dipole has been studied on the inside. The photons from those quantum dots come out with handedness, like us, a right-handed or left-handed person, and quantum information is carried by this handedness of individual photons. As such, sorting them out, the different pathways, is an important task for quantum information processing. The research team has developed a new way of separating differently handed photons and efficiently harvesting them for further processing down the road. The findings of this work are expected to contribute to developing high-speed, single photon sources, a critical component needed in quantum photonics. And this is the Professor of Space Technology, Advanced Physics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.